In this video, we're going to discuss the triggers, how we convert triggers. So the tool automatically generates 4 files for each form. First file is a plain text file having the original triggers. So as you can see, this is the original trigger. Each one, like you have form level triggers. Now this is the block, the trigger when you form instance, and so on. Well, the target of this file was actually to extract all the code from the form. As you know, in Oracle forms there are no architecture, like there is no MVC architecture, something like this. So you need to extract the code from the screen in order to successfully convert it. So this is the main purpose of this file. But actually we found out that the text file is not that good. So we changed our strategy and we started generating XML files. Well, XML files are really much more powerful. Like you can say that we have form level triggers, block level triggers, and procedures. In block level triggers, we can also have item level triggers. So by using the expand feature from the XML files, it's much easier in order to navigate through the code, the original code by Oracle Forms. So this is generated by the tool and it generates only the items having triggers. So you don't have to search which trigger having, which item is having triggers. So this is automatically generated as one file with, of course, the search capability. It's available. Okay, this is the original code from Oracle Forms. Now, what about being converted to Java? In the MVC architecture, you are allowed to write the code in either the controller layer or model layer. We do not write any code in view layer. From technical point of view, you cannot decide directly which part you should write the code. Like you cannot detect that this should go to controller or model. A developer must decide. So what you are doing in the tool is that you are generating both files. As if I'm going to write the whole code in the controller layer, and as if I'm writing the whole code in the model layer. So a developer must decide. So let us open sample file. Okay. So as you can see, for each trigger we're generating a signature of a Java method, but having the same name in Java format. First thing, Arabic text and any non-ASCII character should be converted to Unicode. This is automatically done by the tool. So let us explore some features that are automatically converted through the code. Now this is a comment. Okay, it has been automatically converted. So comments are preserved inside the code. Now this non-ASCII characters have been converted to Unicode. Okay. Now if we check, for example, companies block with key direct. For example, let us check this trigger. It has a cursor, select statement, and whatever. Okay, so this is key direct in companies. So I can easily navigate to key direct in companies. Okay, now let us see how the tool converted the code. Okay. Now this is declare. We don't have declare in Java, it must be removed. Okay, the tool automatically removed it. Now this is cursor, its name is primary key, and this is select statement, select X from found customers, where company ID equals bind variable. Now let us see how this has been converted. Okay, it has been converted exactly like Java. So this is the select statement, this is the bind variable, and it has been converted into its equivalent by getting the attribute through the iterator and the attribute name. Then this is the standard preferred statement result set, getting the transaction using ADF utils. Then we are getting the value here. Okay, plus successfully closing the statement and result set. Okay, now primary dummy character of 1. Okay, now whenever we check such simple code, it has really a lot of challenges. First, in PL you write the variable name then data type, while in Java we write the data type then the variable name. This has been automatically done by the tool. Now in PL you must specify the size of the character. In Java we don't have something like this. It's string and it's only string. There is no size. So as you can see that the data type has been converted to string and the size has been removed. Also primary underscore dummy, this is the naming convention in PL because we don't have it's case insensitive. While in Java it's case sensitive, so we need to convert this variable into Java syntax. Okay, this has been done automatically by the tool primary dummy following the camel notation for variables. There is also a hidden thing here, is that in PL you can just write this and that's it. While in Java any local variable must be initialized as 0 for number and null for object. So this has been automatically done by the tool. If you don't have an initial value, we are going to put null for object and 0 for a number. So this has been automatically done by the tool. Also there is a hidden challenge, is that professional developers do not use explicit data types like this. Normally they use table.column %type, getting the type dynamically from the database table and column. In our tool, we're actually detecting this. We're connecting to the database, connecting to the table, connecting to the column, getting its actual data type, then automatically converting it to Java. Of course, this is time consuming for a developer and prone to errors, while a tool is 100% accurate and very fast. Okay, let us continue through the code. Now it's checking that if company ID is not null, then. Of course, in Java we don't have then, so it has been removed by the tool. Instead, we have curly braces, and if you have nested if statement like this, it will be automatically generated. Okay, now we have this is not null. In Java, it does not equal to null, so this has been also automatically converted. Okay, open primary cursor. Well, there is no equivalent in Java for this. Well, actually, it has been converted through the SQL statement and using the result set. So basically, what we can automatically detect to be converted, we're leaving it as is, so that the developer is going to check it. Of course, there will be compilation error generated by the developer that there is something wrong. So the developer is going to check it in exactly the same place as in the original form, so that he can correct whatever is missing. Okay, now this is a global. Okay, in our tool we are detecting all globals and parameters and generating them with standard setter and getters, adding them in session. This is the equivalent in Oracle ADF. So all parameters and globals have been converted. So imagine that this class is almost 90 lines for just 10 forms. Imagine that I have 1,000 forms. Of course, this file can be very big. So the tool automatically generated this file completely 100%, no need to do anything. Also, regarding the procedures used, if you are calling a store procedure, database store procedure or function, whether standalone or inside the package. Also, this is the standard Java code that is going to call the store procedure from database. This has been also automatically generated by the tool. Even we support here tables and custom types. We generate the tool, or from the tool, everything related to custom types as well. So we support all types found in database. Okay, this is a number. Let's see how this has been generated. Okay, double. See, this is how we convert, because it is a number, so we convert it into double with the initial value as 0, as you can see here. Okay. Now for the if statement, if you need to compare in PL, you use one single equal sign, while you use a colon and equal sign if you need to assign. Well, in Java, the equal is only single equal, and comparing is done using two double equal signs. So this has been also automatically generated by the tool. So from technical point of view, like, okay, we parsed your code. If there are select statements, we're generating it with the standard prepared statement result set and the DB transaction from ADF. If you have bind variables, we're detecting them. If you have parameters and globals, we're 100% converting them. Also for store procedures, we're 100% generating the code that is going to call them. Equality, if statements, loops, cursors, all these structures are automatically converted. So again, this is what we prove, is that from code point of view, we are really doing a lot of effort, and we are really generating a lot of code. So from code point of view, like, it can be 60 or 70% automatically converted, can be higher in case you are using standard structures. But anyway, the tool will for sure save your time in order to successfully migrate your code into Java from the original code found in the Oracle forms. So again, once more, we prove that the tool will really enhance and reduce the time required in order to convert to ADF, as we have seen through these features. And also, we are going to explore in next videos, like, how to really complete the code taken from the tool. This is what we are going to explore in later videos. The final thing that we emphasize here is that the tool is very powerful in even converting very complex code. It's going to save you time. It is going to be very accurate and precise. This is our benefit from using the automated tool.